Now, you guys don't have a lot of time to let this sink in. Test is next time, so you better do the homework tonight and then do the review on Tuesday night so you're ready for the exam. The review's right here. Okay? Test has 8 questions on it. This is what the review looks like, by the way. Yeah. The first 4 questions are partial fraction decomposition questions. Yeah. Then the next 2 are systems of nonlinear equations, kind of like question 3 on the quiz. Okay. The last 2 are coming from this section that we're doing right now. Okay. This is your test pretty much, these 8 questions. Yeah.
So the first one was just like
the first 4. These questions 1 through 4 are like those 2 questions right there. Test is on Wednesday. Anyway. Example 1. Graph. 2x plus y is less than or equal to 4. Two things, well, really 3 things you got to consider. What type of a graph is it going to be? Linear, quadratic? Next thing is it going to be a solid type graph or a dotted graph? And then the third thing is, where do you shade? Those are all things you got to consider. What type of graph is this? Linear. Solid line or dotted line? Solid line. This should all just be a review. And then we got to figure out where to shade it. So I'm going to rewrite this into slope-intercept form. Y is less than or equal to negative 2x plus 4.
Why?
Y-intercept is 4. Are we... Should I just wait for you guys to finish?
No.
Not everybody does, especially me. Okay. Y-intercept is 4. Slope is negative 2, so you go down 2 over 1. Solid line, because it's less than or equal to. Okay, and then we got a shade. Now, I don't care how you were originally taught how to do this. I want you to do it this way, because this is the safest way. Test points. Okay? Choose a test point. We're either going to be shading above or below, so I can test the origin 0, 0. If 0, 0 satisfies the inequality, we shade there. If it doesn't satisfy the inequality, we don't shade there. Okay? So if x and y are both 0, we end up with the statement 0 is less than or equal to 4, which is true. 0 is less than or equal to 4, so that means the test point should be in the shaded region, which is underneath. Because it's the easiest point to choose. Okay? If your graph happens to pass through 0, 0, you can't use 0, 0, so what would be another convenient test point? 1, 1, or 0, 1, or 1, 0. You can choose anything as a test point, but normally 0, 0 is the easiest, unless the graph passes through it. Let's try another one. Part B. Graph y is greater than x squared plus 4x plus 4. This is going to be quadratic, right? So it's going to be a parabola. Is it going to be a solid parabola or a dotted parabola? Dotted, because there's no line underneath the equality. It's strictly greater than, and then we got to figure out where to shade. Well, before we graph a parabola, we need to know where the vertex is. And this is still review. This is something you ought to remember. We could put it in vertex form.
That negative 0.
Well, we learned two different ways to do this. You could complete the square, or you could find the vertex using the simple little vertex formula, negative b over 2a. The opposite of b is negative 4. 2 times a is 2. So the vertex is negative 2 comma something. Because this vertex formula only gives you the x value of the vertex. Where does the y value?
You plug it in.
Plug it in. Turns out to be 0. Okay. So the vertex is negative 2 comma 0. We need more than just the vertex to graph the accurate shape of this parabola.
That's fine.
Okay, so now we need to make a table of values. Or we could use the y-intercept. 0 comma 4 is the y-intercept. Parabola is symmetric, so you can reflect that point. So negative 4 comma 4. Now be careful. We already decided it was going to be a dotted parabola. If you graphed it with a solid one, you miss points on a test. Should be a dotted parabola. Okay? Now, test point. This parabola does not pass through 0, 0, so you can use 0, 0 as a test point. Does it satisfy the inequality? We end up with the statement 0 is greater than 4. Yeah, that's false. 0 is not greater than 4, so we're not going to shade where the test point is. We're going to shade where it is not. Where is the test point not going to be? Inside the parabola. So we shade inside the parabola. The only difference between objective 1 that we're doing now and objective 2, objective 2 is going to combine a quadratic with a linear, and there's going to be a double shaded area somewhere. You got to find out where the double shaded area is. You've done this before back in algebra 2. Okay. So one more example though. Part C. X squared plus y squared is greater than or equal to 9. This is a circle. X squared plus y squared. This is a circle. Correct? That's okay for the...
So does that mean we have to actually graph it and do it?
Yep.
I was hoping that because it wasn't a function.
This is a circle. The center is the origin 0, 0. The radius, this is geometry stuff. The radius is 3. Okay? So if you put the center of your circle at the origin and just go over 3 on every axis, is the boundary of the circle going to be solid or dotted though? Solid, because it's greater than or equal to. So try your best to make a circle as perfect as mine.
Here, nice.
Oh,
No, imperfect.
Ah,
shoot.
imperfection.
Right there is close enough. Should be solid though.
Oh.
That was cool.
Oh.
I got it, it's cool.
What's like the spider graph? That's nice that you could draw with the pattern.
Yeah.
There we go. That's a circle with radius 3 centered at the origin. Okay, now we got to figure out where to shade.
0 is not greater, so outside of the circle.
We can use 0, 0 as a test point. We would end up though with the statement 0 is greater than or equal to 9, which is untrue. So we don't shade where the test point is. We shade where it is not, which is everywhere around the outside.
That was beautiful shading.
That's pretty good.
You just shade the whole paper.
Okay. So those are the 3 main types of graphs you're going to have to graph: linear, parabolas, and circles. Now we just got to combine them. Maybe it's going to be a linear with a circle, or it's going to be a parabola with a circle, and you've got to figure out where the double shaded area is. So let's get into it. Objective 2 is systems of inequalities. Yo. Did you get in trouble?
No, it just doesn't believe that I was targeted for a good reason. None of my teeth.
Okay. So example 2.
Last night watching it. I watched it on
My friend was watching it. I was like, I'm going to watch it with you. And he was like,
So
we need to share with everyone. That was actually.
write these directions down very carefully because this is exactly how it's worded on the test. Graph the solution. That just means find the double shaded area. But find the coordinates of all the vertices. That means find all the intersections of where one graph intersects with another graph.
So are we finding like restrictions?
That's an extension of this. We're not going to have time to get through it today, but
My brain can handle this.
so let's first graph and shade the first one. X minus y is greater than 0. Yep. If we were to rewrite this in slope-intercept form, I'm talking about the top inequality, it would be x is greater than y, and then switching that, y is less than x, y is less than x. That's a linear graph with the slope of 1. What's the y-intercept though? The origin, 0, 0. So there's a point at 0, 0. You go up 1 and over 1. This is going to be a dotted line. Okay. To figure out where to shade on this one, though, we have to choose a point other than 0, 0 because this graph passes through 0, 0. It also passes through 1, 1, so you can't use 1, 1. So what about this point right here? What's the location of this point right there? That's 1, 0. We can use 1, 0 as a test point. If x is equal to 1 and y is equal to 0, this is the statement you would have. 0 is less than 1. True or false? 0 is less than 1. So the test point satisfied the inequality. So what does that mean? We shade where? Towards where the test point is because it satisfied the inequality. So we're shading below that one. Okay, now for the other one. If you want to write this in slope-intercept form, that's the inequality y is less than or equal to 2x minus 4. So negative 4 is the y-intercept. The slope is positive 2. So you go with 2 and over 1. It's a solid line. Now we got to figure out where to shade on this one. Because this line doesn't pass through the origin, we can use 0, 0 to test for this line right here. So if we use 0, 0 to test the solid line, then we'd end up with a statement 0 is less than or equal to negative 4. That's false. So the test point didn't work. That means we don't want to shade towards the test point. We shade on the other side, away from the test point. So choose a different color here. Shading away from the test point.
I'm just showing a different direction.
So what you need to identify very clearly on the test, so it's clear to me, because if it's unclear, I'm going to mark it wrong if I can't tell. You need to clearly identify where the double shaded area is. However it is you want to do that is up to you. I would recommend just making it a little bit darker. So this is the double shaded area right here.
Possibly labeling.
Yeah, you could. Yeah, so there's the double shaded area. That's the solution to the system of inequalities, but the directions were very clear. That's the first thing you do, graph the solution. But the second thing you do, and if you forget this, you get the problem half wrong. Find the coordinates of all the vertices. What that means is, where's the intersection? Okay? You got to solve this algebraically. Graphically, this is going to be very inaccurate. How do you solve algebraically where one line crosses with another line? System of equation. Okay? That's what we learned about last time. Turn this into a system of equations to solve for that intersection point right there. So x minus y equals 0, and 4 plus y equals 2x. This is going to solve for that intersection point. So you can solve this however you want. Substitution, elimination, doesn't really matter. If x minus y equals 0, doesn't that mean that x equals y? So you can make a substitution here. If x equals y or y equals x, I'm going to take that value and substitute it in for right here. So this becomes 4 plus x equals 2x. Y equals x.
Oh, okay.
So 4 equals x, which also means 4 equals y, because y equals x. So the intersection there of those two lines is the point 4, 4. That's an example of two linear graphs, which you should have done a lot in Algebra 2 last year. Let's try another one, a little more complicated. Example 3. Y is greater than or equal to x squared. X plus y is greater than or equal to 6. So the top one's pretty easy. Y is greater than or equal to x squared. What type of graph is just plain old x squared? It's a parabola whose vertex is 0, 0. Okay. 1, 1 is also on the graph. Negative 1, 1 is on the graph. Because it's greater than or equal to, it's a solid parabola.
Would you ever get us two equations where one is equal to and one is greater than the last one? Like, where would you ever get like x?
I suppose it's possible, but not on this. Now, this graph passes through 0, 0, so you're not going to want to use 0, 0 as a test point. But yeah, let's use 0, 1 right here. 0, 1 is a test point. That means y is equal to 1, x is equal to 0. So you'd end up with a statement 1 is greater than or equal to 0. That is true. So the test point you've chosen, or that I've chosen here, satisfies the inequality. So you shade where the test point is. Inside. Okay, for sake of time, this one right here, x plus y is greater than or equal to 6. That's a linear. Okay, that's a linear graph whose x and y intercepts are both 6. And it's a solid line. Now this line does not pass through 0, 0, so you can use 0, 0 as a test point. If you do, you end up with a statement 0 is greater than or equal to 6, which is false. 0 is not greater than or equal to 6. That means we're going to be shading away from the test point that we've chosen. Okay. So again, on the test, I would extend that parabola and clearly identify that the double shaded region is this above the line in the top piece of that parabola. Okay, that's part 1 of this problem. Part 2 is to find those two intersection points. Right there and right there. Okay, that's done by turning the system of inequalities into a system of equations. Y equals x squared and x plus y equals 6. Instead of inequalities, solve them as equations to find the two intersection points. So if y equals x squared, then this bottom equation becomes x plus x squared equals 6. So x squared plus x minus 6 equals 0. That factors into x plus 3 times x minus 2. I know sorry I'm going so fast, we're running out of time here. The two values for x are x equals negative 3 and x equals positive 2. Now, you always ought to double check your graph. Do these look like about the x values we should have? Negative 3 and positive 2. Right? Positive 2 right here, negative 3 is about that intersection point, so that seems pretty reasonable. What we got to find now are the y values. If x equals negative 3, y is equal to x squared, so y would have to equal 9. So one of your intersection points is negative 3 comma 9. And if x equals 2, then y equals 4. So the other intersection point is 2 comma 4. That seems pretty accurate. 2 comma 4. This one should be negative 3 comma 9. You don't need to label them on the graph, no, but they've got to be marked somewhere that I can see them. So if you're not going to label them on the graph, maybe box them in so I know where to find them. Last one. Then we're done. Example 4. Yep. This is all. It's not going to get any more difficult than that last one.
Is this the whole 10.9? This is like all of what 10.9 is?
Yep.
This is actually not that bad. Circle.
It's going to be a circle and a line. So the circle has a radius of 5 centered about the origin. In 10.9, since we really haven't studied a lot about circles, they're always going to be centered around the origin. Remember, it's a dotted circle because it's just less than 25. It's not less than or equal to. Now, we saw it shaded on this one. We've got the circle that's dotted. If we tested the point 0, 0 for x and y, we would have the statement 0 is less than 25. Which is true. 0 is less than 25. The test point we chose negative or 0, 0 works. So we shade inside the circle.
Will there be any problems where the two lines don't intersect?
It's possible. What would that mean?
It means there's no.
It doesn't mean that there's no solution necessarily, but there wouldn't be any intersect. That's a good question, actually. Let's do a little side note here. If these two lines don't intersect, does that mean that the answer has to necessarily be no solution?
No.
Because this line could be shaded underneath right here, but the other line could be shaded above, like this. So isn't there still an intersection?
Yeah.
I mean, there's still an intersection of shaded regions, right?
Yeah.
There just wouldn't be any vertices to find. So. Well, with any like this here, there's infinitely many points that could be inside of this shaded region. You understand what I mean? So many of these are going to be infinitely many. Anyway, does that answer your question? Does that answer whose question was it?
Mine.
Does that answer it?
Yes.
Okay. Next one, x plus 2y is greater than 5. How do we graph that?
What is the
2y is greater than or equal to negative x plus 5, and then you divide by 2. So you have y is greater than or equal to negative 1/2 x plus 2.5. So the y-intercept is 2.5. The slope is down 1 over 2. Solid line. Now, deciding where to shade, we can use 0, 0. We would end up with the statement 0 is greater than or equal to 5. Which is not true, so we're not going to shade towards that test point. We shade away from it.
small solution?
So the solution of this system of inequalities is this top right portion of the circuit. True, true. Now, you guys, real quick before the bell rings, we have 3 minutes. The book is going to ask you, in addition to doing all this, is the region bounded or unbounded? What would you classify this? They're talking about the double shaded region. Would you classify this as bounded or unbounded? Bounded. Okay, but the others, like example 3 here, this double shaded region right here, it's unbounded. So they're going to ask you one of those two things. Is it bounded or unbounded? We haven't found the vertices of this last one, though.
I'll find it later.
We've got time. This one's bounded. We haven't found the vertices. The coordinates where they intersect. So x squared plus y squared equals 25. And y equals negative 1/2 x plus 5/2.
The other y is 5 minus x.
Now, would you guys want to make a substitution like this involving fractions?
No.
I certainly would not. So rather than solving this equation right here for y like we did down here, what would be probably easier? Couldn't we solve this for x? Wouldn't this be x equals negative 2y plus 5? Wouldn't that be the same thing? This would be much easier to substitute than this y equals equation. Unless you want to use fractions, it's up to you. So I'm going to take this x and substitute it in. Okay? So instead of x squared, this becomes negative 2y plus 5 squared plus y squared equals 25. That's written as 4y squared minus 20y plus 25 plus y squared equals 25. The 25s will cancel out. So this becomes, how many y squares do we have? 5. We have 5y squared minus 20y equals 0. Factor out of 5y. You have y minus 4 equals 0. What are the two values for y?
0 and 4.
Y equals 0 and y equals 4. So if y equals 0, x equals 5. And we can see that clearly on the graph, but if you went back and substituted, you would get the same thing. X equals 5. So it's 5 comma 0 for one intersection point. Hold on. If y equals 4, what do we get for x? Negative 3. X equals negative 3, so the solution is negative 3, comma 4.
Thank you. Have a nice day. See you on Wednesday.
Test on Wednesday. Print out the review.